to another XB, which as rotor. The rotor XB is going to send the signal to our PSOC, allows the PSOC to generate a PWM waveform to drive our DC motor.
This is our PSOC design. One UART, which is for XB communication, 4 timers for our encoders, and 2 PWM generator for our motor control. And there is our sending XB, and the other side is our receiving XB and PSOC. We are using MATLAB to generate the angular speed and linear velocity to control the motor. Now I'm going to send through some linear velocity and angular velocity. As you can see, we generate a PWM waveform. By changing them, we can change the speed of the motor.
We use a software XTCU to set up the XBs. There are a few really important parameters need to be initialized. First, all our XBs should have identical IDs to achieve communication between all the XBs. And all our XBs has a baud rate of 15200 to achieve a fast communication. One XB were set up as coordinator. Other XBs are set up as rotors. Latency and distance were tested by our team. We use 2 XBs to communication between each other. The received signal was showed on oscilloscope. By recording the signal by a stopwatch, we record the time. All the time were subtracted by 0.5, which is the human reaction time. The maximum communication range we achieved is 50 meters. After 50 meters, there is no communication or made. Now I'm going to talk about our control system for our DC motor. Our DC motor will create some error when it's running. Therefore, we need a control system to be able to reduce the error. Our group decided to use classic control model, which are P, PI, and PID. Those models are widely used in the DC motor area. We created a MATLAB code for testing our DC model because during the COVID situation, we cannot physically test it. So we have two kind of noise. One is input distributes, the other is sensor noise to simulate the real environment. For our P controller, clearly showed on step response. There is a steady state error. No matter how you tune the P controller, it cannot be avoided. Therefore, P controller cannot be used. The simulation result showed PI and PID has really similar result. Both of them can tune the controller well and can achieve a good measurement speed result. However, because PI has fewer parameters, therefore we decided to use PI rather than PID because it's easier to control and cost efficient if we decide to use a hardware controller.
From this research, we have now identified that 3D printable robot design will make it more accessible for people that would like to play robot soccer or learn from it but cannot use it. We have updated our PCB and made it more cost efficient with updated components from that of the original system, which was designed in the early 2000s. we've identified that XB is the most ideal protocol in terms of communication for the robot soccer system due to its low latency and good reasonable distance. We've also identified that PI control is the most ideal for DC motor control because of its simplicity and because of its accuracy when controlling DC motors. Thank you.